Hi, everyone. Good afternoon. First off, could you tell me whether or not this appears right side up or upside down or in the correct orientation? Because I want to make sure you can see it properly. So if it gives me, if it has the correct orientation, if you could just say yes or thumbs up or something. And happy birthday, Rosie. I hope you have a wonderful day today. Esteban, thank you for your thoughts. Maybe towards the end we could do that. Um, so what we're going to do today, we're going to do activity 89. It is the first activity in Unit F. We are coming down the pipe at this point. We have very few lessons left. There are no more than 10 lessons left in the rest of the unit. Actually, there's less than 10 lessons, including this one. So we'll probably be done within 3 weeks, and the last couple of weeks of school will be the opportunity for you to make sure that every lesson is turned in so you can get the highest grade possible. So especially since there's no final, you want to do great this marking period. I know that some of you have taken the second test. I will post the retake on Monday. I was going to post it on Saturday morning, but I don't want people doing work over the weekends. Your weekends are yours. So I'll post it Monday morning or late Sunday night so that it's there when you get up Monday morning. So if you're interested in a retake, you're welcome to do a retake. And of course, as always, I will look at the two grades and drop the lowest grade. So you won't have both the test and the retake impacting your average. It'll just be one of them. Okay? So anyone have any questions? How does this look? Does this look straight? Can you read it properly, or does it look backwards? Okay, great. All right, so we're going to start with the introduction to activity 89. Okay, and what we're working on is waves. This may or may not be very clear. Don't worry about it. So Gemma looked outside after days of rainy weather. It was finally a bright and sunny day. Ma, I'm heading outside to meet Sam, she called to her mother. She grabbed her headphones and headed for the door. Remember your sunglasses, said her mother. Gemma swept them off the kitchen counter. She left and put them on. Listening to music, she walked down the street and joined her friend Samantha at the corner. Hey, said Sam, pointing out Gemma's sunglasses. My glasses are just like those, only blue. Gemma took out her headphones to be able to hear her friend. Well, why aren't you wearing them? Oh, I don't like wearing them. They make my nose itch. My mom says the sun can damage your eyes. Have you ever heard of that? We have a lot of bright days around here, so maybe you should wear them. Yeah, you're probably right. But aren't you worried about hurting your ears with those headphones turned up so loud, said Sam with an equal concern for her friend. How is sound energy transmitted? Can light go through an object? What is ultraviolet? How are sound and light waves similar? In this unit, you will learn about several kinds of waves and investigate the transmission of sound and light. You will also investigate situations in which some waves may be harmful to your health. So we're going to talk about waves. Okay? All right. So Jose and Jenna were talking at lunch. The cafeteria was noisy, though, and Jose was having a hard time understanding Jenna. Jenna thought it was weird that he wasn't able to hear her very well. Later, they talked in a quieter place. Jose, I'm a little worried about your hearing, Jenna said. What do you mean? Jose asked. Well, I notice that sometimes you don't hear me call to you. I have to repeat myself really loudly. Well, actually, sometimes I don't hear my teacher right. Like yesterday, I wasn't aware of what she said in class and I ended up doing the wrong thing. You should get your hearing tested. I've had it tested before and it was fine. I don't see why it would change. There are a number of causes of hearing loss. It can be present at birth or develop later in life. Some people are genetically more likely to lose their hearing, although it is not yet known which people are at higher risk. Occupational noises, recreational noises, some medications, and illness can cause hearing loss. When we hear something, it is because sound waves transfer energy to our ears. A wave is a disturbance that repeats regularly in space and time and transmits energy from one place to another with no transfer of matter. Some sound waves are more intense than others. Sound intensity is a measurement of how much sound energy passes through a certain area in a certain amount of time as it spreads out from the source. Scientists measure sound intensity in watts per square meters. A common way of describing sound is with the decibel scale. It is a unit of measure that indicates the relative intensity of a sound. In this activity, you will investigate the decibel scale and how the human ear responds to different levels of intensity. So I'm sure you can see the data table that's here. I know it's hard to read in the book, but I did recreate it here. I apologize. My printer decided now it's going to misbehave and start running low on ink. So we have 5 cards, and we're going to look at the type of sound, the number of squares that are shaded, the total number of squares on the card, the proportion of the shaded squares on the card, the relative intensity, and the decibel level. Now, some of this we're going to have to calculate. Some of it we'll be able to just copy. So these are what the cards look like. And I know it doesn't look like very much, but as you go through the different cards, you can see the different amounts of shading. So let's start with card A. First of all, and I know it's hard to see, but up here it tells us this is moderate rainfall and it is 50 decibels. Okay? So the decibel level here is 50, and the type of sound is moderate rainfall. Now, for this, we're going to have to calculate. So the number of squares shaded, this was very easy to see here. There's only 1 square shaded. So we'll just go ahead and put 1. But there are a lot of squares on this, are there not? So we're going to count them. Now I'm going to break it up by box section. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then this should be 10 because it's a square. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 10 is 100. So the total number of, the first thing we look is the number of box per segment, the segment that I broke up, and it's 100. The number of box segments, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 going across and 10 going down. So that is 10 times 10 is 100 box segments. Okay, makes it easier to count. 100 times 100, 1, and then 1, 2, 3, 4 zeros. So we have 10,000 squares on each individual page. Much easier to count it this way than to count it individually. So 10,000. Okay? And this is going to be 10,000 throughout. Obviously, the number of squares on the page isn't going to change. So we can go ahead and fill this out all the way down. And so the proportion of the shaded squares on the card, or the relative intensity, for the first one is 1 in 10,000. Okay, 1 square out of all of the 10,000 squares are on this card is shaded. Okay, and that intensity is equal to 50 decibels. Does that make sense before we move on to the next one? Okay, thumbs up or yes, anything. Great. Okay. So let's look at sound card B. Now up here for sound card B, it says normal conversation. So someone who is 1 meter away from you or approximately 3 feet away, 60 decibels. So I guess you would say the conversation level that I'm having with you right now is 60 decibels. However, let's just go ahead and qualify that statement. You guys have a computer that, or your phone that you're modulating volume on. So although I may be projecting 60 decibels, that may not necessarily be what you're hearing depending on the volume that your system is set up for. So in this case, this is normal conversation. And the number of squares shaded in this particular case is 1, 2, 3, 4, 5. And then there are 2 rows of 5, 10. Okay, so there are 10 total that are shaded. So it is 10 in 10,000. Or we can put, or 1 in 1,000. And as I mentioned before, that is 60 decibels. Okay? All right, so the next card is card C. And there's a little bit more going on here. So now, and notice there's actually a pattern in the card. So this is 70 decibels. And this is a vacuum cleaner. Okay, so now the vacuum cleaner has, and we're going to have to spend a little bit of time counting here, 1, 2, 3, 4, 5. So there's 5 times 2 rows. There's 10 there. 1, 2, 3, 4, 5. 5 times 2 is 10. 1, 2, 3, 4, 5. There's 5 times 2 is 10. 1, 2, 3, 4, 5. 5 times 2 is 10. It's 10. That's 10. 10 and 10. So far we have 10, 20, 30, 40, 50, 60, 70, 80. And then we have to look at what's going on in the center here. 1, 2, 3, 4, 5. 5 and 1, 2, 3, 4. So that's 20. So 80 plus 20 is 100. Okay. So we have 100 squares shaded here. So this would be 100 over 10,000 or 1 over 100. Okay, if you reduce the fraction. Okay? Let me know if you have any questions. Just go ahead and type it in the screen. I'm going to move on to the 4th sound card D. Okay, and this is a lot more shaded. So we're talking about, at this point, traffic on a very busy street. And this is 80 decibels. So let's go ahead and document. Okay, I'm just going to write busy traffic. Okay, and this is 80 decibels. And let's go ahead and start counting. Now, this is easier to count because they're actually taking individual units. So this is 1, 2, 3, 4, 5, 6, 7, 800. Okay? So we've got 800, 900, 1,000 squares. Okay? Because when you take this, that line in the center actually shows you the separation. So we have 1,000 squares. The decibels is actually written on the card. I know it's a little bit blurry. It's right here. Oh, it'll focus in a second. It did focus in and then I moved. So, but the decibels is written up here. There were some people who told me that they were uncomfortable viewing live because with the conversations that were taking place, they were having difficulties with focusing. And there are some whose parents are working. So since their parents are working and they may be using their computer, they're looking at it later in the day. Looking at the number of views later in the day, the majority of the students are viewing it. So we said 1, 2, 3, 4, 5, 6, 7, 8, 9, 1,000 squares. So this is 1 in 10. Okay, or 1,000 and 10,000, 1 in 10. And the very last card. Now, I'm going to give you a little bit of a preface before I mention this. First of all, this is headphones. Okay. On an MP3 player. Now, this is at full volume. Okay. Full volume. Now, how many of you listen to your music at full volume? Anyone? If you do, say yes. If you don't, say no. Okay. So some of you do listen to it full volume. I'm going to show you what your sound intensity card looks like listening to your music with headphones on at full volume. All 10,000 squares are shaded. That is really powerful. So, the proportion is 1. Okay? So, the proportion is 1 to 1. Now, you like you enjoy your drum survival. I do not blame you there one bit. So, looking at this, you can see that as loud as it can be outside with busy traffic, having headphones in your ears, which means that speaker is taking a beeline to your eardrums. And then on top of that, having it so close, it creates a massive sound intensity. 90 decibels is really, really high, and a situation like this can end in hearing loss. Okay? So, there is a next part here, which I hope does clear up a bit. I know it's hard to see, but you know I do send you pictures when you have to do your assignments. So, with your partner, and let me see if I can adjust this to make it a little bit straighter. I know it's hard to read, but we're going to go through it together. With your partner, examine the data in the table and look for a relationship between the changes in relative intensity and the change in decibel level. Okay? Record your findings in your notebook. Now, the table below, now we just went over the changes in decibel level and the changes in intensity. Okay, the higher the the lower the proportion. In other words, the closer the number of squares shaded to the total squares shaded, the higher the decibel level. Okay? So, the table below shows sound levels of some common sounds. In your science notebook, copy the first 2 columns of the table. Do this by using relationships you determine in step 4 to calculate how many more times intense each sound is compared to a whisper. So, obviously, I'm not asking you to copy this down, but if you have your decibel level or relative intensity, safe range is 0. That is your threshold of hearing. Okay, that is pretty much the lowest sound that you can actually hear. Breathing, okay, that is a decibel level of 10. So if someone is breathing, if you're listening to your dog breathing, that's about a decibel level of 10. Whispering or rustling leaves is a decibel level of 20. So a quiet bedroom or a park is a decibel level of 30. A quiet library has a decibel level of 40. The average home or office is a decibel level of 50. A normal conversation for 1 meter away or a clothes dryer is a decibel level of 60. Vacuum cleaner about 1 meter away. Average road noise 25 meters away. Being inside of a car or headphones used in a quiet environment is a decibel level of 70. Now, heavy city traffic, okay, at the curb. So you're standing at the curb and there's a heavy amount of traffic going on. And then you have a hair dryer, freight train, okay, you're approximately 40 kilometers away, a noisy restaurant or headphone used, most places outdoors. Obviously, if there's noise outside, you have to increase the volume. So that is an 80 decibel range. A diesel truck or a factory floor is a 90 decibel range. So now you can see how your work environment could negatively impact your hearing. Snowmobile, okay, that is a 100 decibel range. So the 15th row of a rock concert, notice the 15th row. What about the first row? Okay, circular saw, again, people who do construction who use circular saws, you could see how this could negatively impact their hearing. And the typical musical instrument, that is 100 decibels. A chainsaw in your 1 meter away or a leaf blower close by, 110 decibels. Injury range, okay, so now you're talking about at this point, you went from a safe range to the risky range. Now you're at the injury range. An ambulance siren. Okay, this is one of the reasons why you're supposed to stay away from an ambulance. A jackhammer. How many of you have ever noticed somebody who's operating a jackhammer wears very large headphones? They wear those to protect their hearing. Front row of a rock concert or symphony and max headphone level, you are at an injury range of 120 decibels. Okay, 130 decibels is the threshold of pain. You would actually feel pain. At 140 decibels, you have a jet engine or firecrackers or a gunshot. That is the reason why gunshots or very loud firecrackers, particularly M80s and things like that, they could actually trigger temporary hearing loss. And then at 160, you have some explosions. Okay? Excuse me. So use the table and data from the sound intensity cards to calculate how many times more intense a noise at the threshold of pain is at that of a whisper. Okay, so at this case, the threshold of pain is 130 decibels. Now, I think we noticed a pattern as every 10 decibels, we go up, we go down by a factor of 10. Okay, so at 100 decibels, could you tell me what this be? What this would be? If you were at 100 decibels, what would this number be? Not 0.5. Remember, we're going by a factor of 10. 1 10,000ths, 1 1,000th, 1 100th, 1 10th, 1. So if we're going, it would be 10. That is correct. If we're going from 90 to 100, this will go from 1 to 10. Okay, what about 110? not 1.1. 1.1 is not a factor of 10. What about 110 decibels? So at 100, we have 10. What about 110? It would be 100. That is correct. What about 120? Anyone have anything for 120? It would be 1,000. That is correct. And what about 130? It would be 10,000. That is correct. So, taking a look at this chart, whereas normal conversation is at 60 decibels and you have a 1/1000th proportion of being shaded, looking at this card, this is 10,000 squares. Imagine having to multiply this by 10? Insane, is it not? Okay, so at this threshold, you would feel physical pain in the drum. And of course, at 100,000 relative intensity, you would have hearing loss. And an instant perforation of the eardrum at 160 decibels or a million relative intensity, your eardrum would be perforated immediately. Okay? Does anyone have any questions, concerns? You only have 4 analysis questions, which I will post today. Other than that, those will be due. Today is Wednesday, so I'll probably go over those on Monday, as well as the analysis questions I'm going to assign tomorrow for tomorrow's activity. So, and that's just because I want you guys to focus on your test. And the test is due by Friday, okay? If you remember our conversation on Monday, the test is due by Friday, 11:45 p.m. That's when the test closing date closes out, okay? So once that closes out, Monday morning, I will post the retake for you to take for anybody who wants it, okay? And as I mentioned earlier, once we're done with this unit, we'll probably be getting close to the window where we would be reviewing for final exams. We would do a little bit of a review, but once that test is posted, your main job is going to be to make sure that all of your assignments are turned in. I am going to be emailing individuals what assignments they are actually missing so that you are aware that you are missing an assignment and what that assignment number is. And I am going to be getting in touch with certain individuals about other matters as well. But other than that, as per request from Esteban, if we can have a moment of silence for our dear Snowball, who unfortunately crossed the Rainbow Bridge on Saturday. So we hope Snowball is at peace. She was a very feisty cat in life, so I'm sure she's going to be giving everybody the business on the other side of that Rainbow Bridge. Any questions, comments, difficulties, concerns? Anyone who posted anything before 11:30 was graded. Obviously, the test is auto-graded, so once you submit the test, you can go in and see how it has impacted your average. But the test is auto-graded, so, but any assignments, I do not recommend you taking the test before turning in your assignments. If you haven't done the sections, if you haven't viewed the videos, it doesn't make sense for you to take the test because you're taking it having missed some content. Okay, that being said, it is due by Friday night. So if you're missing assignments, get those assignments done and please turn them in. Okay, now I recommend that you probably get in touch with some of your buddies that had a habit of getting on and let them know that we don't have as much of an issue with distractions in the live chat if they're interested in coming back. Because although I know people do watch the videos outside of class, it is a little concerning to me that they don't have the opportunity to ask questions. So now that we've pretty much toned down the extraneous chatter and we're focusing, I think the class is much more streamlined and it's a lot more focused on the work. So, all right, guys, I hope you have a wonderful day. If you have any questions, I'll stay on for a moment or two. But other than that, take care, and I will see you guys tomorrow. Bye.